Function rules, tables, and graphs. Our definitions. A function table is a table that organizes the input, the rule, and the output of a function. The independent variables are the input values or the x values. The dependent variables are the output values or the y values. We also know these as domain for the independent variable and range for the dependent variable. They're just more synonyms that we can use in place of those. Our key concept is that there are three views of a function. We can view a function as a rule, for example, y equals 1/2 x plus 3. We can view a function as a table, so where we have our input values or our x values or our domain values. We have our function with our input values plugged in, and then we have our y values calculated based on our middle section here. And then the third view of a function is as a graph. Completing a function table. Model each rule with a table. So our first rule is f of x equals -3x. So our table consists of our input values, our rule with our input values plugged in, and then our output values calculated. So with our input values, I have -2, -1, 0, 1, and 2. If ever you are given a function to calculate output values for and you're not given input values, feel free to go ahead and use these. These are good because they're not too high and they also include some negative and positive numbers. So plugging our input values into our function, we have -3 times -2, which gives us 6. For -1, we have -3 times -1, which gives us 3. For 0, -3 times 0 is 0. For 1, -3 times 1 is -3. And for 2, -3 times 2 is -6. Here's our second example. We have f of x equals 1/4 x. So our input values we're using this time are -4, -1, 0, 1, and 4. Again, a good set because they are not too high and they give us a range of negative and positive values. So for -4, 1/4 times -4 equals -1. For -1, 1/4 times -1 equals -1/4. For 0, 1/4 times 0 equals 0. For 1, 1/4 times 1 equals 1/4. And for 4, 1/4 times 4 equals 1. Let's do our third example. We have y equals 8 minus x. So again, I've got the input values of -2, -1, 0, 1, and 2. So let's go ahead and plug in our input values into the function. So we have 8 minus -2. And again, when you are inputting your x values or your input values into the function, be sure to put them in parentheses. If you don't, it could dramatically change the value that you get for your output. So be sure to put your input values in parentheses. So 8 minus -2 gives us 10. And we have 8 minus -1 gives us 9. 8 minus 0 gives us 8. 8 minus 1 gives us 7. And 8 minus 2 gives us 6. Graphing functions. For y equals the absolute value plus 1. Sorry, the absolute value of x plus 1. That's our function. So our input values are -3, -1, 0, 1, and 3. So plugging in our input values into our function, we have the absolute value of -3 plus 1, which gives us 4. The absolute value of -1 plus 1 gives us 2. The absolute value of 0 plus 1 gives us 1. The absolute value of 1 plus 1 gives us 2. The absolute value of 3 plus 1 gives us 4. So as a relation or as a function, here is our set of ordered pairs that we would use to graph our function. We have -3, 4, -1, 2, 0, 1, 1, 2, and 3, 4. So I've plotted those on our graph. We have -3, 4. We have -1, 2. We have 0, 1. We have 1, 2. And we have 3, 4. And as you can see, as we join our plotted points on the graph together, we come up with this V-shaped graph. And you'll notice that any absolute value functions that have this absolute value of x will always result in a V-shaped graph. Graphing functions continued. Our second example here, we have the function of x equals x squared plus 1. So our input values are -2, -1, 0, 1, and 2. And if we plug in our x values into our function of x, again using parentheses for our input values, we have -2 squared plus 1, which gives us 5. -1 squared plus 1 gives us 2. 0 squared plus 1 gives us 1. 1 squared plus 1 gives us 2. And 2 squared plus 1 gives us 5. So our relation or our function in our set of ordered pairs looks like this. -2, 5. -1, 2. 0, 1. 1, 2. 2, 5. So going ahead and plotting those on our graph, we have -2, 5. We have -1, 2, 0, 1, 1, 2, and 2, 5. So this might start to look like a V shape with the absolute value graph that we just saw, but in fact it's more of a U-shaped graph. And you'll notice that this is what we call a quadratic function, and quadratic functions often contain the x squared value in the function, and quadratic functions will always result in a U-shaped graph. It also could be an inverted U-shaped graph. So this curvy U-shaped graph is called a parabola. So going on to an application question. One charges $3.50 per hour for babysitting. Write a rule to describe the amount of money, which is symbolized by M, earned as a function of the number of hours, represented by H, spent babysitting. So our rule will be M, which represents the amount of money made, equals 3.5 times H, H being the amount of hours spent babysitting. So here's our function table. Our hours will be our input values, and you'll notice I don't have any negative values there because he's not going to work any negative hours. He's only going to work positive hours. So our hours are 0, 1, 2, 3, and 4. Our function is again M, which means the amount of money earned, equals 3.5, representing $3.50 per hour, times H, being the number of hours worked. So if we go ahead and plug in our input values into our function, we have 3.5 times 0 gives us 0. We have 3.5 times 1 gives us 350. We have 3.5 times 2 gives us 7. 3.5 times 3 gives us 1050. And 3.5 times 4 gives us 14. So on our graph here, you'll notice I just have this first quadrant because we're not going into negative hours worked or negative money earned. Hopefully he's a good enough babysitter that they won't charge him to look after their kids. So we have the money earned represented up the side here, and the time or the hours spent babysitting along our x-axis. So our input and output values, or our coordinates, are 0, 0. So we start at 0, 0. Then we have 1 and 350, 1 and 350. We have 2 and 7, 2, 7. 3 and 1050, 3, 1050. And 4 and 14, 4 and 14. Any graph that you see that is a straight line like this, we call that a linear function.